Good morning, everybody. Welcome to a very cold but sunny Monday morning of Chem 1105 with your host, me, Dr. White. All right, a lot of things to talk about. First of all, good morning, Ruben. Second of all, a couple of things. First of all, if you go to Blackboard and look at the announcement, and if you haven't gotten an email yet, you will get it. Let me get to that. You'll see, hopefully everybody sees on their screen, new Chem 1105 organic lecture files. I was looking at them yesterday and thought about it. And this morning I uploaded a new and improved organic lecture slides. That's the file called Chem 1105 Organic Chemistry. So I highly recommend go to Blackboard and download them. All right, while we're here, let me remind you the extra credit project. And let me open it up. And if you notice, the extra credit project, 10, yes, 10 big points. And the due date is the 7th of December, and there's no extra, no late projects accepted. Be sure to read this, how to get your 10 points if you hand this in. Remember, this is not a group project. You shouldn't share your answers with anybody else. Oh, don't you just love blueberry tea in the morning? And let me remind you, email me your project before you hand it in. I'll check it and I'll tell you what's wrong and how to correct it. But you got to do the first thing is send it to me, or during my office hours or after lab before the 7th of December. Talk to me about it and I'll help you. That way there should be no reason each and every one of you want to do the project shouldn't be able to get 10. Yes, 10 points. And I'm looking for, and as I showed you how easy it is, Carmex, I'll be putting on my lips soon, not today. If I look at here, one of the ingredients, phenol, and you could put down Carmex phenol, and it's covalent. Remember, if a molecule has a metal in its name, such as an alkali metal, alkaline earth metal, or just any metal like copper or stuff like that, it's going to be ionic. Again, if it has a metal in its name, it's ionic. Also, some of the halogens you got to be careful with, so that's why you asked Dr. White. All right, next thing. A week from this Friday will be test 4. Whoops, I'm gonna have to have that fixed one day. See, wants to do it again. Oh, it's Bad Humor Monday. But anyways, test number 4, a week from this Friday. I changed the date, sent out an email, also an announcement, but I'll remind you again. And continuing on, a week from today, next Monday, not today, I'll be having cataract surgery on my other eye. Remember, this has been fixed. See, no lens. It works, thanks to Dr. Cabin. And there will be no class a week from today. I'll put out an email to let you know. Also, this Thursday is Thanksgiving. I'll say it tomorrow, but I'll say it again today early. Have a happy Thanksgiving. I hope you can get all the good food you want. By the way, in my family, there's been a tradition. What's the best part of the turkey? Well, there are 2 best parts, but the ultimate best part is the tail. Yes, I love it, and so does my brother-in-law. Unfortunately, passed away 2 years ago. But we finally came years ago to a mutual agreement. We split it in half. The other thing, by the way, in Yiddish, we think of the tail as you're behind, and in Yiddish, that's called the pupik. Yes, pupik. And if you listen, look around, you'll see some people using that in English in the United States, pupik. And we always fought over the pupik until we came to, like I said, a mutual agreement. The other best part is the skin. Oh, boy. But anyways, and we came in our whole family, everybody gets equal parts. You take it off the bird. Oh, is that good? Dangerous, but good. All right. Now, because of Thanksgiving, we will not have classes on Wednesday, obviously Thursday, but we don't meet on Thursday, or Friday. So tomorrow will be the last class of this week, but as a special service to you, I don't have to do this, on Wednesday, I will have my office hour. So if you have any questions, I'll be here. Don't tell anybody I'm being nice. All right, I think that covers everything. Let's get to the good stuff. Wherever I can find it. And there's the good stuff. Now, last week, I was teaching you how to put in hydrogens on an organic molecule. Remember, there's always 4 bonds to carbon. If you don't see 4, the remainder are hydrogens. So you got to do some very serious heavy-duty math, 4 minus something. So what I thought I'd do, one more practice. And here's one for you to practice. And what I'm asking you to do is draw in the hydrogens. And your turn. I'm going to share the fun today. Big time. Oh, one other thing I've neglected to mention, tomorrow and the rest of the semester, which isn't that much, I'm going to start something new. And that is Tuesday tomorrow after lab, right after I talk about the lab, I'm going to invite a few of you into a chat room and I'm going to get to chat with you. I'm going to ask you to turn on your webcam if you got one, so I can see your face and see your real people. And this is my way of saying hello and getting to know you. Because other than a few of you I've met in office hours or afterward, I really only know you as names on the screen. That's pretty sad. So I want to change that. All right, I think everybody's done, so I better get to work. Remember, there's always 4 bonds to carbon. And if we look at this first carbon, there's 1 bond. So 4 minus 1 is 3. Now, if we look at this carbon, there's a bond I'm going to go Technicolor on you. There's a bond there and a bond there. And if we count, that's 2. And remember, there should be 4 bonds to carbon. So 4 minus 2 is 2 hydrogens. And the same thing here, same thing here, same thing here, same thing here, one more same thing here. And now this last carbon right here, how many bonds to it? 1. 4 minus 1 equals 3. So like the other end, this will have 3 carbons. Now, by the way, that's the 2. Now this molecule has a name and it's called octane. And I might have mentioned before, but I'll mention it again. If you go to a gas station here in Northern Illinois and you look on the pump, you'll see a big placard that says for each type of gas they're selling, the octane number. And back about 1905, when they first started selling gasoline, the cars were starting to be used by people as opposed to just being an oddity. The best gasoline had the highest amount of octane and other isomers of octane. Isomers are molecules that have the same number of atoms and the same type of atoms, but are connected differently. And the different isomers of octane, 8 carbons, made this best gasoline. And that became the octane number. Now, I might have told you this, but most of the time you should use, unless you have a Ferrari, Lamborghini, which Dr. White would like one of those, but I don't have yet, or other real high-end, very, very, very expensive car. If you have a normal American or, when I say American, car that's driven on the streets in the United States, you can use the lowest octane number. Now, something I learned long ago when I worked for a company that sold chemicals that are used as additives in gasoline, and got to go to a number of the petroleum companies that make gasoline, that I was taught about additives they use. Now, the most expensive gas has the best additives, but most of the time you should get by on the low octane number, the lowest additives. But about once every 3 months, I let my gasoline go down to about a quarter. Normally, I don't let it go down below a half tank, but that's just my personal preference. And when it goes down to a quarter, I'll fill it with the highest octane gas. And because of that, I'm putting in better additives that helps my car engine. And so I've been doing that for 3 cars now, and it works. All right, now there's another way to draw molecules, and that's for cycloalkanes, which are cyclo means cyclic, in a circle, which organic chemists call rings. And cycloalkanes are represented by polygons. Poly means many, gon sided. And the rule is each bend in a line is a carbon, each end in a line is a carbon, each intersection of a line is a carbon, and hydrogen atoms are not shown. So how do we do something like that? By the way, take note, this is one of the rare times I'll draw a 6-membered ring showing carbons and hydrogens. Organic chemists don't do this. Let's count the carbons. 1, 2, 3, 4, 5, 6. How do you draw that with the line method? A 6-sided polygon, which is a ring. This is a ring. In organic chemistry. And I'm having a good ring drawing day. Just like people have good or bad hair days, I can have good or bad ring drawing days. I also have software that does this, but like this on the fly, I'm going to draw it. Now, I'm not teaching you names, but that's called cyclohexane. And notice in cyclohexane, we have 6 benzenes, so that means there's 6 carbons, and this is the same molecule. Now, I'm going to ask you for this one, how many carbons are in that ring? Your turn. Remember, every bend is a carbon. Time's up. Let's count. 1, 2, 3, 4, 5. So there's 5 carbons in that ring. No, it doesn't look like a circle. Actually, it looks like the pieces of greenhouses in Monopoly if you've played Monopoly. Now, you're going to call that a square. I'm an organic chemist. I'm going to call that a ring. It's cyclic. No, it's a square. Yes, it's cyclic for organic chemists. And once again, how many carbons are in that ring? Your turn. Time's up. This is called cyclobutane. Cyclo meaning it's a ring. And it has 4 carbons. Remember, every bend in a line is a carbon atom. And it has 4 carbons. And this is something you should know how to do. Now, for teaching organic chemistry, I combine 2 methods. And therefore, I might ask, and you should know, how many carbon or carbon atoms are in this molecule? Well, what do? Well, you start counting. Every bend in a line is a carbon. So in this ring, 1, 2, 3, 4, 5. So the ring has 5 carbons. Here's 6, here's 7, here's 8. So the answer is 8 carbons. And here's one for you. How many carbon atoms are in B? Your turn. Time's up. Let's look at this ring. How many bends? 1, 2, 3, 4, 5, 6. So the ring has 6 carbons. And right here, how many carbons? 1, 2, 3. So 6 plus 3 means that molecule has 9 carbons. Now, I should tell you, the greatest of all organic chemists is Mother Nature. And Mother Nature loves 6, 5, and 4 carbon rings. In penicillin, there's a 4, it's called heterocycle carbon and other atom ring. In your hormones, there are 3 6-membered rings and 1 5-membered ring. Yes, your hormones, otherwise known as your steroids. Now, I mentioned this briefly, but I'd like to go back again and cover it, and that is functional groups. What is a functional group? It's a specific grouping of atoms in a molecule, and they always undergo the same type of chemical reaction. So a functional group is when you have a certain group of atoms together in an organic molecule, and they always undergo the same type of chemical reactions. Now, there are a number of functional groups. One would be a double bond, and we would show that like something like this. There's the double bond. Now, you could have a triple bond. Each line in organic chemistry, we don't show pairs of electrons in Lewis structures. Now, one line is a single bond, but notice this molecule I just drew had 3 lines between those 2 carbons, and that's called a triple bond. Now, in alcohol, now in organic chemistry, we use the letter R to denote something that just has carbons and hydrogens. It can be 1 carbon, 5, a million. It can be in a ring or doesn't have to be in a ring. And an alcohol has this structure, a hydroxyl group, OH, oxygen, hydrogen, on a carbon in a molecule. An example of an alcohol is this molecule. See the hydroxyl group on a carbon. This is called ethanol. And it also is called now, you don't have to know the individual names of functional groups, but I thought I'd show you it. And ethanol, also known as ethyl alcohol, is that tiny little alcohol molecule found in beer, wine, and hard spirits, which I am not in any way implying you should ever drink, even though Dr. White likes his vodka. But anyways, and that's the little molecule. If you consume too much, you get inebriated. By the way, inebriated is a fancy word for getting drunk, which you should never drive. And here are other functional groups here. And Dr. White likes all of them. I love ketones and aldehydes because I did my PhD thesis on ketones and aldehydes. I worked with carboxylic acids, carboxylate anions, esters, amines, quaternary ammonium salts in the chemical industry, and also amides. Now, important thing about functional groups. How do you find a functional group in a molecule? And I'll be subtle. Hint, know this. Well, you find a functional group in a molecule by looking for anything that's not a carbon atom, hydrogen atom, or is not a carbon-carbon single bond. So whenever you're looking for a functional group, you look for what's ever not a carbon atom or hydrogen or a carbon-carbon single bond. And that's going to be always a functional group. And guess what? It's time to play. Oh, I got to do this. That fun game, circle the functional group, 2 points each. How do you play that fun game? I'll show you. And let's look at this molecule. Now, one of the things of being a good organic chemist is, and Dr. White likes to think he's a good organic chemist, and I think I am, because the number of patents I have. They have been commercialized. Look for what's different, what's not carbon, what's not hydrogen, should get your attention like that. And if I look at this one, ooh, an oxygen, and therefore I can circle that. Now you don't have to know this, but this is called a ketone. Oh, this is fun. Let's do another one. And if we look at this molecule, by the way, the different atom is connected to carbon, and that carbon is part of the functional group. And if we look at this molecule, ooh, a nitrogen and 1, 2 oxygens. So here's one functional group, here's the second one. By the way, this is called an amine or amino group. This is a carboxylic acid, and this is the structure of an amino acid. And the word amino acid comes from combining amine, functional group, and carboxylic acid. And the names you don't have to know, but you do have to know how to find functional groups. So I'm going to let you have some fun too. And let's play that fun game. Circle and name the functional group, 2 or 3 points each. Your turn. If it looks like I'm having a lot of fun, I am. You're on my home court now. Remember, I'm an organic chemist. Look for something different. Look for what's not a carbon-carbon single bond or a carbon or hydrogen atom. That's going to be a functional group. All right, let's do this. Look for something different. What's not carbon, what's not hydrogen? Ooh, a nitrogen, oxygen, another oxygen. And this is called an amine, this is an alcohol, and this is called an aldehyde. And there were three functional groups in there. Oh, let's do another one. And while you're doing that, I'm going to go downstairs to my refrigerator to get something for show and tell. I'll be back in a minute. Keep on working. I'm back. All right, let's look for the functional groups. What's not a carbon-carbon single bond or carbon or nitrogen is a functional. Ooh, look, a double bond, two lines between carbon. This is a functional group. It's called an alkene. Oh, look, a sulfur, and this is called a thiol. So those would be those two functional groups. Now, one of the questions when I teach organic chemistry, and I don't teach it anymore at COD, I still teach it at Elgin Community College, is why are you learning this stuff? Why learn organic chemistry? Well, the obvious answer is someone said you got to learn, take this course, and you want to get a good grade. I'm being honest, but why learn it? Well, let's take a look. All right, thumbs up, people. Do you see beta carotene on your screen? Thank you, Mackenzie. All right, now, beta carotene has this structure. Every bend in a line is a carbon, every end in a line. So there's a carbon here, the ring, each bend is a carbon. At my level, this is how we draw things. Did I tell you organic chemists are lazy? And look at all the double bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 double bonds in beta carotene. That's a lot of double bonds, a lot of carbons. Notice that it has 2 rings, each 6 members, 6 carbons. These are called CH3 groups, methyl here, and each bend in a line is a carbon. That's a lot of carbons. Well, why learn about this? Look out. It's Dr. White's show and tell. How many of you have ever seen a carrot? It's a big carrot. I get mine at Valley Produce. I like them bigger because when you slice them, you got bigger and it's nice in soup and other things. But anyways, here's a carrot. And since we're in color, living color, this is alive. I'm alive. I think it's alive. But anyways, it's orange. Why is a carrot orange? Beta carotene. The molecule with all those double bonds is what causes this to be the carrot, this color. Now, your body, when you consume, no, I'm not. By the way, what's up, Doc? For those of you know Bugs Bunny. But when you consume carrots, the beta carotene in your body breaks it down to another molecule called retinal. Retinal, that sounds like retina of your eye. And retinal is an important chemical to help you see better. So I guess it's true. Bugs Bunny sees better because he eats a lot of carrots. So next time you see a carrot, that's caused the color by an organic molecule with a lot of double bonds. Now, if you look at a tomato, a different organic molecule with a lot of double bonds, it looks similar, but not the same. The beta carotene makes tomatoes look red. Yes. So molecules have an important part in our daily life. Functional groups do. Remember, double bonds make carrots look orange, and it helps with your eyesight. I don't know how much. I go to my eye doctor a week from tomorrow after my surgery. I'll ask him, do carrots really help improve your eyesight? So you should know how to find functional groups. And we did some functional group practice time. Now, there's one functional group I like to talk about that plays a very important role in our life, and that's the thiol. And a thiol is a carbon with a sulfur that has a hydrogen. And it's like an alcohol, but instead of OH, you have SH, a sulfur with a hydrogen. And forget about the nomenclature. But the important thing about thiols is they stink. And when I talk about stink, I mean stink really bad. They really do. And where can you find thiols? I'll talk about T-butylthiol in a second. The odor of onions and garlic are due to thiols, but Dr. White loves onions and garlic. But what's one of the most stinkiest things you can think of? A skunk. And a skunk odor has the following thiols. By the way, there's a carbon here, but we don't show it. My software doesn't. And notice this has a double bond, plus this is the thiol. And here's another thiol. These two molecules have been identified as the key components in the defensive weapon of a skunk. In other words, when a skunk sprays at somebody or an animal, somebody else, or some animal, when it thinks it's going to be attacked, and uses it as a defensive weapon. If you've ever driven by somewhere where a skunk let loose, oh, does that stink? Now, if you notice, that adds up to 70%, and I assume that the other 30% is water. Now, I have to tell you a very tragic, sad story. Back in about 1937, in a town in Texas, they had a school. It was K through high school, K through 12, all in the same building area, or I think there were two buildings next to each other. And one building had younger K through 5. The other, I think it was 5 or 6 through 12, high school and grammar school, high, middle, upper, higher, whatever. But anyways, in that town and nearby, they had found a lot of oil. And back then, when they struck oil, one of the things they found was a organic molecule called methane. You know methane as natural gas. If you've ever seen pictures of oil well fields, they burn it off. I don't know about now, but for many years they did. Well, the school said, hey, can we have your natural gas? And they put in different gas heaters in the rooms in the high school. Now, this is in 1937. And unfortunately, what you don't know is, you can see one right there, anytime you turn something on electrical with a switch, inside there's going to be a spark, unless you have explosion-proof switches, which I worked in a plant, actually more than one plant, where we had those because we were working with hydrogen, which is also quite explosive. So if there's anything explosive and you turn on or off the light, or something like a vacuum cleaner or anything else electrical, that spark, when you do this, will cause an explosion if there's something around it that's flammable. Well, it turns out whoever made these pipe fittings for this school, and there are two versions of the story, did a bad job, and it was leaking natural gas into the building. And if you read the accounts, a week or so before this horrific accident that occurred, students were complaining about headaches, natural gas they were inhaling. Well, so there's two versions. One is somebody turned on a belt sander in a wood shop or a light, and the school blew up. The other version is they were having a social in the gym area, and in the kitchen area, the person was watching the chili, I think it was the version I've heard, left, and the burners went out and leaking gas. Somebody turned on a switch, lit a cigarette lighter, boom, same thing. About 300 students and teachers were killed. A lot others were severely injured. It blew the school to pieces. And because of that, the Texas legislature had a commission to find out how to make natural gas safe. And you're probably saying right now, wait, I can smell natural gas. I mean, yours you can, because they put something in there. And that's what that commission, then the Texas government, state government enacted, and now it's throughout the whole United States and about the whole world, that a certain chemical is put into methane, natural gas, so you can smell it. And that smell, what you smell in natural gas is not the natural gas, it's what they put in. It's called T-butyl-thiol. And it's a thiol with a sulfur in it. How stinky is it? They only put 4 pounds of thiol, T-butyl-thiol, in about 4 billion, yes, billion pounds of natural gas. That's how stinky it is. They just have a little, it's called 4 parts per billion, and that's something you should be aware of. Now, the beauty of learning functional groups is that, and let me make this a little larger for you. Is that a reaction of a certain functional group will yield the same product or type of product most of the time. There are a few exceptions, but mostly it's not. And I like to teach you 2 reactions that you should know. The first one is combustion. If you take a saturated or unsaturated hydrocarbon, react it with oxygen, you'll get CO2, water, and heat. And this is how we cook our food, heat our home, drive our cars, by this reaction. So let's look at an example. This is called the general reaction. And this is a roadmap. But if I have a specific one, oh, by the way, unless we have to, organic chemists never balance equations. If I were to ask you, give the I might make it 4 points, 3 or 4 points each. Give the reaction product or products for the following reaction. And what do? You look at this and say, oh, it's only carbon and hydrogens. This is a hydrocarbon. And actually, it's a saturated hydrocarbon. And if I react it with oxygen, you also need a little spark. What do I get? Carbon dioxide plus water. And now, what are the products here? Guess what? Carbon dioxide plus water. We don't put down the heat because that's not considered a chemical product. So let's have you try one. By the way, this is propane. And when you burn it, combust it, you get carbon dioxide and water plus the heat. And that's how you cook your things on your barbecue. Ran out of room, so I can bend the arrow, organic chemist. And it's your turn. What would be the product or products for the following reaction? 3 or 4 points each. And it looks like we're out of time. So I'm going to go ahead and do this. This is octane. What is that? A saturated hydrocarbon. And when we react that with oxygen, with a spark, here's the general reaction. Saturated hydrocarbon, oxygen gives CO2 plus water. Carbon dioxide plus water. And therefore, the answer here is carbon dioxide plus water. You also get heat. By the way, this is octane. And this is a reaction going on in your car. With that, I went a whole minute over. I'm sorry. It's time for me to go because time flies when you're having fun with organic chemistry and Dr. White. And with that, gang gesund. I'll see you tomorrow. Goodbye. And don't forget, I have my office hour. Thank you, Ruben. You have a nice day too. I have my office hour tonight. If you have any questions, don't forget there's a lab due tomorrow. I'll see you tomorrow. And don't forget, double bonds are responsible for the orange color of carrots, including big carrots. Bye now. Gang gesund.